I did. Okay, we're going to do this without that. Okay, ready? So polynomial and sinusoidal functions, lesson number 5. It says this: amplitude and period. We're going to start talking about the characteristics of this wave that we have going on. Okay, in the last lesson, we investigated the graphs of sine x and cosine x. We did not look at cosine x. Just for fun, take your calculator and type in y equals cosine x in y2. Leave your y1 and just do y2. And tell me what is the same and what's different.
It's the same pattern, but it goes in different. And together that looks like spaghetti.
Yeah, so it's the same. It's just shifted over, isn't it?
Yeah.
Just a little bit different. It does it. Where does it cross the y-axis? At 1, yeah. And sine crosses it at 0. So it looks exactly. It has the same height, right? It's the same. It's just shifted over. Okay, let's keep reading. In the next 3 lessons, that's all you have left of your grade 12 mathematical high school career. 3 lessons. Ready? In the next 3 lessons, we investigate sinusoidal functions. I need you to listen, not talk, please. Functions whose graphs take the shape of a sine wave. In these lessons, we will investigate functions of the form y equals, notice the a, sine of bx plus c, close the bracket, plus d. You noticing all that stuff? It's going to be important. It's in your book. I'm reading along. Determine what effect altering the parameters of a, b, c, and d has on the graph of the function. And in this lesson, we are just going to focus on the parameters a and b. So can we make this graph get stretched out? Can we make it go higher and lower? Can we shift it? Yes, we can do all of those things to it. Okay? By definition, a periodic function is a function whose graph repeats regularly over some interval of the domain. We talked about the tides as they come and go. We talk about sound waves. We can even talk about the waves on the ocean if you want to. The length of this interval is called the period of the function. Do you understand? It's a cycle that's repeating. It's called the period. The amplitude of the periodic function is defined as half the distance between the maximum and minimum values of that function. You must know these terms. The period is how long it takes for the cycle to repeat. That should make sense. The amplitude is how far it is, get this, from flat either to the top of the wave or to the bottom of the wave. That's amplitude. Now I'm going to say that one more time. Amplitude is how far it is from level, if there were no waves on the ocean, if it was calm, from there either to the top, to the crest of the wave, or to the trough of the wave. That's amplitude. Understand? It can be found by taking the very maximum height and the very minimum height and cutting it in half. I don't usually use that formula, but it is there for you in your book. You can notice it. Get it? Max subtract the min divided by 2. Okay. Right. Okay. We'll just see if that, we're getting somewhere. So it's on. Okay, let's keep reading. Example 1. Determine the period and the amplitude for the following periodic functions. Tell me what it means by period. How long it takes for the cycle to start over. Look at the first letter A. How long does it take before it starts over? 8. Okay, you need to write down there the period of that. Go P equals 8. That's what I'm writing on my page right here. P equals 8.
So it's just one of these.
A complete cycle, right? So at a crest and a trough before it starts over. Okay, so not just the crest, not just the trough, but the entire thing. Okay, on class example number 1, can you tell me the amplitude? We're going to say A equals. What does A equal for?
7. 10.
From flat to the top. 10. Yep.
Which one are we on right now?
A.
Oh. So then it would be. I thought you just said it was 8.
8 is the period.
Oh.
The period is how long it takes to repeat. The amplitude is how high the wave is. Okay. Okay, so it's 10. The amplitude is 10, and the period is 8 for that first question. Understand? Understand?
Yep.
Okay, next. Letter B. I'm on letter B, okay? Letter B says, what do you think the period is? Careful. 7? Wrong.
6.
5.
Not 5. It's 6. Okay, can you do this? We're going to go.
Shift it over.
Because does it start at...
Where does it start?
It starts at -1. Yeah.
And it goes to where?
7.
To 5. From negative 1.
5.
Okay, or here's a better way, maybe, if it's easier. Go peak to peak.
Oh.
Okay, so you've got some stuff going like this. How far is it from here, from peak to peak? How far is that? Well, from 3 to 9 is 6. Last I checked. You know what I'm saying? All in favor, say aye. Okay, so the period, I'm going P equals 6. And what's the amplitude? Now, it's kind of hard because you don't have your flat line. That line that's in the between, I like to put it on there. But can you, from the formula, can you find it? Just go from the very highest, which is what? 6. And then subtract the -2 and you get 8. Cut in half is 4. So the amplitude, cut in half. Okay, so the amplitude is 4. I like to actually draw the dotted line to show my midpoint. If you could see it on here, I go like, when I have this on here like this, I actually figure out where that line goes. And then from that line to the top is your amplitude. Okay, so this, okay. Now let's go on to class example number 2. Ready? The partial graphs of y equals sine x and cosine x are shown to you. What is the amplitude of sine x? A. What is that? What does A equal on sine x? 1. What's the amplitude on cosine x? 1. What's the period on sine x? 2 pi. It takes until 2 pi before you have completed the entire circle. The entire cycle, I should say. The crest and the bottom. Okay, what is the period on cosine? It's also 2 pi. Very.
It's hard for me to follow when it's not on a screen.
I understand. I don't know what to do. I know I could just do this. I don't know why it's not working at all. How would I do this? Do you suppose that's why?
Why?
I don't think so. Okay, so for sine, I'll just write it up here. Sine x, we have the amplitude is 1 and the period is 2 pi because that's how long it takes to complete the entire cycle to there. Correct?
2 pi.
Isn't that the, okay, and for cosine x, sorry, what did you say, Emma? Yeah, yep. And for cosine, the amplitude is still 1. And guess what the period is? From crest to crest, peak to peak, 2 pi. Okay, so they're very, very similar. All right, turn the page. It wants you to explore what happens when you put a number in the front of your y equals sine x. So I would like you to take your graphing calculators, and we're going to put in there y1 and y2. Okay, so in y1, I'm going to type in sine of x. So you should already have it, should be in radians in your mode. And do you have sine of x in there already?
Yes.
Okay, in y2, I want you to put 2 sine x. We're going to see what happens when we change the little number in the front. Hit graph and explain to me the difference between the two functions.
It goes up and down lower.
Oh.
But
Yeah.
it's
So-
the same point.
It has like a,
Okay.
Yeah, it has like
Okay.
a higher peak and a
Okay, the peaks are higher and lower, but the intersection points are the same.
Yeah.
Yeah.
Agreed? Okay, excellent. What do you think would happen if you put a 0.5 in front instead of a 2?
a little bit smaller.
Be a little bit flat. In fact, okay, with your with your 2 in front, what's the maximum value of this function? 2 sine x. Is it 2?
I don't know.
Looks like it.
I think so.
Look at your picture. Looks to me like it's going up and down to 2 and negative 2. Correct? Yeah.
Yep.
You know what we just changed? What's that called? How high the graph goes, how high the wave is. What's that called?
Maximum.
Okay, maximum, but what's the word we just learned? Amplitude. So in your book, that little number in the very front of it, if I put a 2 in front of the sine x like that, that's the amplitude. You with me? Okay, so the little number in the very front of sine x determines the amplitude of your function. Okay, so this little 2, I'm saying this on both, is the amplitude. Okay, I'm not going to go through all their exploration. We're going to go down the page. Okay, so go to the middle of the next. It says exploring the graph of y equals sine bx. What happens if I change the number here? Okay, what happens if I change, instead of the number in the front, what does the b value do? Take your calculator and leave your y equals sine x, but take the second function and put the 2 in front of the x instead. You with me? You're following?
Wait, say that one.
I want you to type this y equals sine of 2x into your y2 function. And let's check and see what happens. Hit graph.
It makes the
Oh.
bumps like arrow words.
Okay, it makes it go more often, doesn't it?
Yeah.
Now you have a lot of little waves. How about the height? Did it change the height?
No.
No, the height didn't change, but we have a lot more waves. You know what it just did?
2 waves per normal.
We have 2 waves for a normal wave. So in other words,
It's a mess.
the cycle is repeating in a shorter amount of time. Noah, are you listening to me? I'll say it one more time. We complete a cycle in less distance. So instead of completing 1 cycle in 2 pi, I'm completing 1 cycle in 1. That would be even more. So, okay, come with me. In your book, I don't know why I can't show it to you. I want you to, in the very bottom box on page 370, there is a little chart that we're going to put in there. It says y equals sine x. Are you with me on the chart?
Yep.
Okay. What is the amplitude of plain old y equals sine x? What's the amplitude? How high up and down does it go? No. The plain old sine x just goes up and down to 1. So put 1 in the first amplitude box. Okay. What's the period for plain old y equals sine x? How long did it take to repeat? We've already written this down once. 2 pi. Write 2 pi in the box. Okay. Let's go to the next box. The next box says y equals sine 2x. So in y equals sine of 2x, is the amplitude still 1? Yes, because it's the number in the front of the sine that affects the amplitude, and that number hasn't changed. So my amplitude for this y equals sine 2x is still 1. But what about the period? Did that change? Yes. Now the period is just a pi.
And the next one.
The period is pi. It completed them faster. Okay? Now, take your calculators. We haven't done this one yet. Take your calculator and type into your y equals. In y equals sine, I want you to put 0.5x instead of 2x.
Same amplitude, longer period.
Oh.
Is it
Okay.
4 pi?
So now we're talking about sine of 0.5x. The amplitude was the same. So in the box, put down amplitude of 1. That didn't change. The height of the waves did not change. But the period now, is it taking more time or less time?
More.
Oh, we only have, by the time I get to 2 pi, I'm only halfway done. So guess what the period is? 4 pi. Mm-hmm. Are you in radian mode? Well, that would be the reason. Okay? Understand? So the little number, okay, so we'll turn the page. I think it'll show you, we'll summarize all of the above. Okay, ready? So on page 371 is kind of the, here's everything you need to know. Ready? The amplitude and period of y equals a sine of bx. This little a in front of the whole thing is where you get the amplitude. That one is easy because a stands for amplitude, right? Okay, so this little a, I'm doing this on both screens. This is amplitude. Pardon me? No, it is not. You'll have your y equals thing, but it won't tell you what each letter stands for. The b that you have here is not the period. Remember it was 0.5 and my period was 4 pi? It's not that number. And remember back here, when I had a 2 there, it turned out to be a pi. So it's not the period, but it's how you get the period. Ready? If you want to know the period, you always take 2 pi and you divide by whatever that b is. Write that down somewhere. Is it on your page? It is in there. See in the little box on page 371? It shows you that the period, b is not the period, but b helps you find out what the period is. On the side on page 371 at the top, there's actually a box.
Yeah.
In that box, it has this information.
Oh, it's just science information about where it's on here.
Yeah, nope. This is what it's telling you. So the b that's in the formula is not the period, but it helps you determine the period. You take 2 pi, which is the normal one, and you divide by b. Yes?
Are we going to have to memorize the amplitude equations?
Yes, you have to know that. Yes. Mm-hmm.
It won't be in there.
You know what? Check in your back of your book, but I don't think. It might have the formula for period in there.
Yeah, that's the formula.
Does it have the formula for period? Okay, that's the only one you don't have, but by the time you're done, you won't need to know the answer for that. Okay. This, by the way, is in radians. The 2 pi part is radians. If you were talking about degrees, anybody remember how many degrees 1 pi is? I just mentioned it briefly. It's not what you think. He thought it was a whole circle. Yeah, pi is 180, so 2 pi is 360. So if we were talking about in degrees, we would go 360. But I don't think you'll have to know that. I think you can just go with the 2 pi. Okay, so let's go down to class example number 3. Ready? For the following. Okay, Anson. Class example number 3. Are you ready? The one they want us to work on is this one. It says 0.5 sine of 3x. They want to even know the amplitude. What's the amplitude of that? What is it? What's the amplitude? Quick. 0.5. Noah, the amplitude for this question is 0.5.
Oh,
what is the period in radians?
It's probably 2 pi divided by 3.
2 pi, and then we divide by the b. This is b. 3 is b. Right? We're going to divide by this b. So the period is 2 pi over 3. And can someone tell me what the maximum and minimum value for this question would be? Remember, what does sine normally go up and down to? 1. So now what is it going to go up and down to? 0.5. So the maximum value would be 0.5, and the minimum value would be what? Negative 0.5. Exactly. Okay, so our max is 0.5. I'm writing this twice. The minimum is negative 0.5. Okay, y equals 6 sine of 3x. Is everybody with me?
No.
6 sine of 3x. What's the amplitude?
6.
What's the period?
Wait, do we have to?
Oh,
Do you want us to solve that, or just
No, that's it. That's all you're supposed to do.
2 pi over 3?
Yeah, no, that's good. The period is also 2 pi over 3. So the amplitude is 6. Period is 2 pi divided by that b, which happens to be is a 3. And what's the maximum value we're going to get on this question? 6, and the minimum? -6. Very good. Let's do letter C. Okay. If in doubt, you have a calculator that can help you with this. Anybody know what the amplitude is in here? Careful. No,
No, it's 2.
it's just the 2. The negative sign flips it down, but instead of going up to 2 and down to -2, now it goes down to -2 and up to 2. It's still the same. It's just flipped over. So the amplitude is still 2. What is the period? 2 pi over 0.25. Now, what is 2 divided by a quarter? Isn't 2 pi a quarter? Yeah. What is 2 divided by a quarter? If you had $2 and you split it up into quarters, how many people could get a quarter? 8. So all of a sudden this is 8 pi. Your period for letter C is 8 pi. Now, before we get confused about what it's going up and down to and what my max and my min is, why don't you take your calculator and type that in there and tell me what you get? Type in all of C into y equals and tell me what your maximum value is and what's your minimum value, just to be sure.
It's a straight line.
Oh boy. Can't be. Are you in radians? Did you forget an X? Okay.
So for the P, if we can make it into like an even number, then switch it.
Yeah, like 2 pi. I don't.
It's gonna be like 2.2 or whatever.
I want it in terms of pi.
Okay.
So usually, okay, for these questions. Oh, so maximum is still 2. The little negative thing, it flipped it down so it went a different time, but it's still going up and down to 2. So maximum is 2, minimum is -2. Okay, ready? Class example number 4. You with me? All right, can you tell me what the amplitude of this picture is?
Yes.
3. Do you understand why it's 3, everyone? We're on class example 4. Do you understand why the amplitude is 3?
Yeah.
Okay, good. Can you tell me the period?
2 pi over 2. 2 pi over 2.
All you have to do for this is tell me, when does it start to repeat itself? No, like from starting,
X.
that's actually a pi.
X.
Okay, from 0 to pi over 2 is just the bump. You have to do the next trough and start over. So at pi, it starts to build itself again. So here's kind of what I say. If you want to do it in the middle when the bump is about to grow, go to the next place the bump is about to grow. You understand what I'm saying? And that will help you. So it's coming like this, it goes down, and there it starts to grow again. So how far did it go from beginning to there? And it's pi. Okay, so what would the values of A and B, we're supposed to determine those, and write the function. So ready? Write down sine of x. Leave yourself a little space. So I have sine, I know it's going to be y equals something sine of something x. What goes in the first slot? 3, the amplitude, right. Okay. Now, remember, my period is not what goes in here. This is not the period. This is a letter B. But we have a little formula that says that period is equal to 2 pi over B. Hold on. My period is pi.
What? Yeah, it is.
Isn't that right? No. So if my period is pi,
So that means B is 2.
what does the B have to be? It has to be 2, doesn't it? Yes. So this has to be a 2 right there. Can I give you a little hint? If P equals 2 pi over B, then if you did all your cross multiplication and division and everything, you would get B equals 2 pi over P.
Wow.
Can you believe me on it? Yeah, you can just switch the P and the B around. So B is also equal to 2 pi over P. Oops, over P. So you can just do that if you want to. That helps you. So 2 pi over what would give you just the pi? It's a 2. Okay, let's go on. Letter C, ready? Graph the function on a calculator, and the function we just created right here, y equals sine of, or 3 sine 2x. Put that on your calculator. And determine to 2 decimal places the value of the function when x is equal to 5 pi over 6. So take your calculators and type that function in. Clear all others.
I wonder where it's a lot of squiggles.
Yeah, a lot of squiggles. Is it going up and down to 3 like you thought?
Let me see.
Should be, right? Going up and down to 3?
Yes.
Okay, good. And what are we supposed to do? We're supposed to find the value of the function when x is equal to 5 pi over 6. Who remembers how to put that on my graphing calculator? When x is equal to trace. So I'm going to hit trace, and I'm going to say 5 pi over 6. And tell me what it is to 3 decimal places. Negative 2.598. Did you all get that?
I think glitched out. What did I do?
Negative 2.598, wasn't it? 2 decimal places would be 60. Negative 2.60. Good to go? Okay, we're almost done.
Mine, I don't know what happened. The windows changed and everything crashed until I turned it off and turned it back.
Okay, I'll have to come help you after. Okay, go to the next question. Go to class example number 5. We have one less left thing to do, and I'll come in and help you with that after Anson. It says the partial graph shown represents the sinusoidal function f of t is equal to a sine b t that has a maximum value of 3 and a minimum value of negative 3. State the amplitude. What's the amplitude? Good. And what's the period? Now look at this picture. 6 is only half of the deal, right? So yes, the period would be 12. Now, as soon as you have that the period is 12, we don't put p into the function. We put in b. B. Bob. B. Okay, bravo. Okay, you have that p is 12. You need to figure out what b is in bravo is going to be. What's our little formula for that? 2 pi over 12. Understand?
How many decimal places do you want?
So, no, I don't want any decimals at all. So this is going to be pi over 6. Agreed? So the b value is pi over 6.
Oh, you don't solve.
Don't solve that. So now I'm going to write on my function, it's going to be, we decided that the amplitude was 3 sine of pi over 6x. That is your function. And if
What?
you did,
Oh, yeah, sorry.
because this is your b, your a was 3, we found that one pretty easy.
Yeah.
So when you find your p values, what I'm trying to say, p does not go into the equation. B goes into the equation. So you have to go do a little bit of work to find b and then put that number into the equation. Understood? Okay, you have some homework to do. Go do it. I'm going to show it again right here.
We have a minute left.
Oh, good.
We have flex. One?
That's not right.
Wow.
Wait, try and get as much work as you
Oh,
can.
flex. I have flex.
Oh, there it is.
And this is cool. I have to go to drama.
Yeah.
Oh, yeah.
Okay.
All the
Take your book home.
I'll try to forget. I'm kidding.